Now let's do the construction of the second envelope, the second folder. The second folder will be 1B, kinds of quadrilaterals. In all, we will have 6 cards in this. These 6 you will write on the flap which I had shown you, or on your yellow folder I had shown you. So this will hold 6 cards. So you will write 6 in Arabic numerals. 1B will be written on the top right corner. That will be for your reference. Kinds of quadrilateral will go in the middle. This will go on the name slip, the small slip that we make. This will go behind the card and the slip. Okay, so let's make the square. You know already now how to make the square. I will repeat it over here because again you will have to make a square. So in this set you will need 2 squares. Yeah, those were your basic shapes. So let's do this again. Straight line, mark a point. I'm going to measure out 10 centimeters on this. Keep it ready, or I'll mark it here. So this gives me my first 10 centimeters. And here again we will need to make our 90 degrees at the 2 points. At this point and this point we will need to make 90 degrees. So let's do that. Place the point exactly on the point and this line along this line, and mark 90 and mark 90. It's very important that you are very perfect when you place this. Okay, try to be as perfect as possible so you will not go wrong and you will get perfect figures. Let's join this. So this gives us the direction of the 90 degrees. And now we need to cut out 10 centimeters. 10 centimeters, I already have it ready here. Let me check one more time. Yes. Let me cut out 10 centimeters and 10 centimeters. And then I join these and I get a perfect square. So this will be my square. Cut it with your paper knife. Place the steel case and then cut it. Your steel case should be on the inner side of the figure, and then you cut here. Don't keep it like this and cut. Keep the scale on the inner portion, so you know the inner portion gets good support, and then if there is any problem on this side, it will happen on this side, not on the inner side of your square. Okay, so hold it always on the inner side. Press it hard and then give it one nice sharp cut. So you will get a perfect square. This was your first figure. Now let's look at the rectangle. Rectangle will be 1B2. So rectangle will go, this name will go on the slip, and this will go behind the card and the slip. We are going to construct a rectangle of 10 centimeters by 7 centimeters. Now a rectangle, let's make a plan. So this is what a rectangle looks like. So we are going to make this 10 centimeters and this side we are going to make 7.5 centimeters, and your angles are going to be 90, as you know. So this is what a rectangle looks like. Okay, is this a rectangle where this is 7.5 and this is 10 and you have 90 degrees? Yes, it is still a rectangle. Yes, so don't worry too much about the orientation of the figures. Okay, we don't keep correcting the children if they place it the other way around. This is still a rectangle whether you place it this way or this way. So let's draw the rectangle first. Draw a straight line, mark a point. We need 10 centimeters. I still have my 10 centimeters here. Let me check. Yes. So I'm going to mark 10 centimeters. Off. Now I will need to make 90 degrees at both these points. Just like the square, exactly like the square. Make sure that the point is here and the line is sitting on this line. Same way on the other corner. This gives us the direction. Remember, when you're marking angles, it's just giving you the direction. It is not going to give you the length. So just elongate it like that, okay? Now we need to cut out 7.5 centimeters. So I'm going to keep it at 8.5 and mark it off at 1. So that gives me a 7.5. And now we join this. So we have a rectangle with sides 10 and 10, and this will be 7.5. Okay, again use your paper knife to cut this rectangle. Okay, this will all these figures, after they are cut, they will be centered on the card. Place it exactly in the center. Measure from all the sides. Make sure that the picture is exactly in the center of the card. Okay, so this is your rectangle done. Now let's look at the rhombus. Now, what is a rhombus? A rhombus again has all the sides equal. It is like a square, but it is, so the square stands straight like this on 90 degrees. A rhombus is tilted. It has all the sides equal, but the angle is not 90. The angles have tilted. So let us see how we are going to make the rhombus. Now the rhombus, so let's make a plan. All the sides are going to be equal. So we are going to make all the sides 9 centimeters. And this angle is going to be 60 degrees. And this angle is going to be 120 degrees. In a quadrilateral, the adjacent sides, the adjacent angles add up to 180 degrees. So this will be 60. So this will be 120. So that's how we are going to plan our rhombus, and then all the sides will be 9 centimeters. In a rhombus, all the sides are equal, so all the sides will be 9 centimeters. Let's start. Let's see how we draw the rhombus. Straight line, mark a point, mark off 9 centimeters. So if I place it on 1, I'll have to mark it at 10. So I got my base. Okay, now at these 2 points, so let's call it A and B. At A and B, I will need to construct my angles. Now look, okay, so this is my first arm. Now I need to go 60 degrees from here. Okay, so on your set square, you see 60 and you see 60. You need to figure out which 60 you're going to choose. So since we are going to move from here and like this, so and this is my first arm and my second arm is going to be here. So let's place this here, and this is where you will start counting. So let's place this along this line proper. Now this is where I will start counting. This is going to be my 0, 0, 10, 20, 30, 40, 50, 60. So this is going to be my 60 degrees, not this mark. Okay. So this gives me the direction of the 60 degrees. As I told you, it doesn't give you the length. The length will depend on the protractor, isn't it? If you use a bigger protractor, then you will get it further off. So the angles only give you a direction. They don't give you the length. Okay, so here we have marked 60 degrees already. Now at this point, at this vertex, we want to mark 120 degrees. So now this is my one arm, and the second arm is going to be like this, 120 degrees. So I have to start counting from here, from this side. So let me place the protractor here. My one arm is here, so I have to start counting from here. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So my 120 comes here. This gives me the direction again of the angle. So now we have marked 60 degrees and 120 degrees. Now we need to cut out 9 centimeters again out of each of these. Always look from top, because you may have a parallax error. If you look from the side, it will look different. If you look from top, it will be different. So always look right from top and mark. So we marked 9 centimeters each, and now we get a perfect rhombus. All the sides are equal, and this angle is 60, this is 120. All the sides are 9 centimeters. It's like a square, but it is tilted. So that's how we construct a rhombus. Now let's look at a trapezoid. The trapezoid is a trapezium. It is a quadrilateral which has only one pair of opposite sides parallel. In this case, these two are going to be my parallel sides, which are parallel, and this angles are going to be 90 degrees, and my base is going to be 9 centimeters. So this is my plan, and this is how I'm going to execute it. So first I draw a straight line. Mark a point, and I'm going to mark out 9 centimeters. So if I place on 1, I have to mark it at 10. Okay. This is my AB. I have marked AB 9 centimeters. Now at A and B, I need to construct 90 degrees angles. So same way, I will place this protractor so that this line is along this line. Mark my 90 degrees here and here. 90 degrees comes out to be the same from both sides, so you don't really need to count. Let's join this. So you get the direction of the 90 degrees. Now from one side we will cut out 8.5 centimeters. So I'm going to put it at 9.5 and mark it off at 1. So this is my 8.5 centimeters, and this is going to be my 5 centimeters. You construct it like this, you cut it out, but when you paste it like this, so that this comes at the base. Okay, paste it like this. So these are my parallel sides, and these two angles are 90 degrees. That's my trapezoid. Trapezoid is a special type of trapezium. A trapezium is a quadrilateral with one pair of opposite sides parallel. Now let's come to parallelogram. Parallelogram has both the pairs of opposite sides parallel. So it's a quadrilateral, it's a special type of quadrilateral. It's a special type of rectangle actually, or rather a rectangle is a special type of parallelogram. So you have a parallelogram, it's a quadrilateral, opposite sides are equal. So it's a rectangle, but it is tilted. Okay, so when those angles become 90 degrees, you get a rectangle. Okay, now the angles are tilted. So here, this is our plan now. The base is going to be 9 centimeters, 60 degrees and 120 degrees, like the rhombus we did. But in a rhombus, we had all sides equal. Here, this side is going to be 6 centimeters. So these opposite sides are going to be 6 centimeters, and these opposite sides are going to be 9 centimeters. So this is a parallelogram. And rectangle is a special type of a parallelogram, whereas a square is a special type of a rhombus. So let's draw the parallelogram. Draw a straight line. Mark a point. Mark of 9 centimeters. So now here again we will have to make our 60 degrees and 120 degrees. I'm going to place this dot over here and this line along this line. Once I have it, so this is my first arm. So my second arm is going to extend from here. So I start counting from here. 0, 10, 20, 30, 40, 50, 60. This will be my 60 degrees. And for this side, I will have to start counting from here because my one arm is here. So I have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. These two will give me my directions. Extend them. And now we need to cut out 6 centimeters of each of these. So I'll place my scale on 7 and mark it off at 1. So this is my 6 centimeters. This is my 6 centimeters. Let me join them. And I get a perfect parallelogram. Okay, so it's like a tilted rectangle. Opposite sides are parallel. So this is parallel to this is parallel to this. Two pairs of opposite sides are parallel, and each of the angles, this is 60, this is also going to be 60, this is 120, this is going to be 120. This is 9, this is going to be 9, this is 6, this is going to be 6. So this is my parallelogram. Now let's come to trapezium. Trapezium is a parallel, it has only one pair of opposite sides parallel. These two are parallel. Okay, so let's draw the trapezium. We'll make a straight line of 10 centimeters. Mark a point. I think I still have my 10 centimeters here. Yes. So I'm going to mark this 10 centimeters. I always prefer to keep this ready, 10 centimeters. It really helps. Okay. Now we will have to mark the angles. So you need 75 degrees. So this is my one arm. I place it here. I'll have to start counting from this side, right? Because this is my first arm. 10, 20, 30, 40, 50, 60, 70, and halfway is 75. Now let me mark 75 on this side. We'll have to start counting from here. 10, 20, 30, 40, 50, 60, 70, 75. Right? These two gives me my directions. And now I need to cut out 7.5 centimeters and 7.5 centimeters. So I'm going to place my scale at 8.5 and cut it off at 1. And join this. So I get my perfect trapezium. These two sides will be parallel, and this is 10 centimeters, and these angles are 75 degrees each. Okay, So you can cut this trapezium out. One pair of opposite sides parallel. This is also called an isosceles trapezium because these sides are equal. So this is also called an isosceles trapezium. Okay. So that's it about the quadrilaterals. This completes our second group. Nema.